Like I was saying, there will be some curves that in principle we could chop them up into pieces, and each piece of the curve could be the graph of a function. However, that can be a lot of work. And again, it doesn't generalize very well. I would need different tricks for each different curve I'm interested in. Now, as an example of this, I've got an equation over here on the left. Y on x equals the tangent of the quantity x squared plus y squared. Okay, it's an equation. I can write it down, and I can ask Desmos to light up all of the points on the xy plane where this equation is true. So for some values of x and y, the equation will be true. For other values of x and y, the equation will be false. Now, before I turn it on, you might wonder to yourself what kind of graph this is going to make, what kind of curve it's going to make. And it would at least make sense that the picture is not going to pass the vertical line test, because why else would I make it my example? So I know that the tangent function, whatever number I give it, the tangent function can produce any real number. And then I would need to find coordinates where y divided by x is the same number as the tangent of x squared plus y squared. So let's go ahead and take a look at this curve like so. We get a very interesting picture here. So sort of a double spiral shape. In fact, this is something that even Desmos is struggling to graph and show us properly. As we get farther away from the origin here, Desmos is sort of sputtering a bit. And all of these places where the line trails off, it should be continuous, just that the computer does not know exactly what to be doing. Let's zoom in a bit and it will look a little nicer. As I was saying, this is something that we should be able to find tangents for, right? So pick your point. Maybe you want it there, or here, or here, or here. And this curve looks smooth enough that I should be able to find tangent lines at each of those different coordinates. And once I know I've got tangent lines, then I can do all of my normal calculus stuff. I should be able to find arc length. If I wanted to do, say, revolve this figure around the x-axis, I should be able to do that and calculate how much surface area there is. Or if I wanted to find the amount of area encapsulated by this curve, I should be able to do that too, right? How much area is in this region right here, or in this region right here, or so on. All of the normal calculus stuff. In order to find those, I would need to have a function, and I would need to have an antiderivative. But it's not clear to me what is an efficient way to slice up this curve into pieces where each piece is the graph of some function, right? So inside of this box, not a function. Why is it not a function? Because it fails the vertical line test right there. What about inside this box? Inside this box, this segment of the curve, that could be the graph of a function, because inside of this box, it passes the vertical line test. However, even if I chose to slice that up there, I still need to find my formula for this function. And it's not really clear how I would do that based on this equation. So there's got to be a better way to represent this curve than what I'm currently doing.